Hello, nice to have you all with us. Welcome to the fourth of the Rescale Solutions Live webinars. This is a series featuring hands-on demonstrations of the top science and engineering applications on Rescale, including Converge, which we'll go through today. My name is Jolie Hales, and I will be your moderator. Today's focus, as I mentioned, is on scaling up simulation of internal combustion engines on Rescale using Converge CFD software. So I also wanted to make you aware, switch my slide here. There we go. I also wanted to make you aware that the next webinar in this series will take place 2 weeks from today on Wednesday, July 1st, and will cover fast-tracking CFD designed for space exploration using NUMECA CFA. And you can find registration information on rescale.com or on any of our social sites for that. All right, without further ado, let's go ahead and get started. So as we proceed, I also wanted to let you know that you can feel free to write any questions that you might have in the question window in this platform. You should see a place for that. And then we'll take some time to answer questions at least at the end of the webinar. We may pick up a few along the way, but at the very end, we'll definitely make sure to take any questions that we may have not gotten to throughout the presentation. And we have two presenters lined up today. First is our featured guest presenter, Cooper Burns, who is the principal engineer and HPC team lead at Convergent Science. So Cooper has been working at Convergent Science for nearly 6 years. He leads the Converge HPC development team with a focus on improving Converge's scalability and parallel performance. And he looks forward to pushing Converge even further as the industry moves toward exascale computing. I apologize, I'm being Slack exploded and I can't seem to shut it off at the moment. Well, you know how it is working from home. Our second presenter is Bernardo Mendez, who is a solutions architect at Rescale. With a master's in computer manufacturing, Bernardo has a 13-year background working with CAE tools in the automotive industry. First as a chassis development engineer and later as a technical specialist in hardware-in-the-loop systems and multi-body dynamics applications. And he enjoys helping customers unleash the full potential of HPC in the cloud through his work as a solutions architect at Rescale. All right. Wow, something must be really important for me to pay attention to right now. At this time, I will go ahead and turn over webinar control to Cooper from Convergent Science. Cooper, can you hear me? I'm going to go ahead and give you screen share power.
I can hear you. Okay.
Beautiful.
Can everyone see my screen, I hope?
We can indeed.
Hi, everybody, and thank you, Jolie, for the very nice introduction. I'm going to talk a little bit about Converge and why we think it's a great tool for all your CFD needs. I'm also going to talk a little bit about some of the improvements that we've made for Converge 3.0 specifically. And I'm going to mostly be talking about improvements that help push us into sort of this cloud computing and high parallel realm that Rescale is in. So Converge is a general CFD software package. We specialize in predictive flow, spray, and combustion modeling. Sort of one of the big selling points of Converge, and something that we're very proud of and we think is very powerful, is our ability to generate a high quality mesh automatically at runtime. So in the CFD industry, one of the biggest workflow bottlenecks in most CFD packages is the amount of time it takes for the user to generate a high fidelity mesh in order to run CFD on their application. But in Converge, we're actually able to generate that mesh with no user intervention when you actually run the case, and we're able to continuously update that mesh as the case runs so that we can capture transient flow features and add mesh or remove it where it is or is not needed. We have a huge number of physical models, various turbulence models, combustion models, and things like that for the users to choose from. And we also offer a huge suite of user-defined functions so that you can add customization to various models or add your own models or change how models in Converge work. Converge, we've run simulations in a lot of different industry applications, some of the main ones being IC engines, after-treatment systems, gas turbine combustors, pumps, compressors, some biomedical applications, rockets, and in the oil and gas industry. This is sort of a high-level workflow or guide to the Converge workflow that our users use every day. I think that later in the presentation, Bernardo is going to kind of show us how Rescale fits into the picture and how it's very easy to use this same workflow and incorporate Rescale's cloud computing capabilities. But to sort of briefly touch on how easy it is to set cases up and run them in Converge, these are the sort of 4 steps you'd have running a CFD simulation with Converge. So the only thing we need to generate a mesh is a surface file and a watertight geometry that you actually want to run CFD on. So once you have your model in CAD, you can import that directly into Converge's front end, user-facing setup application that we call Converge Studio. You can then set up all your boundary conditions, choose your models, specify what type of simulation you want to run, things like that right in that front end application. And that will then allow you to export files that the Converge will then read to actually run the simulation. So once you've exported those input files, you can launch Converge, whether that's on your on-prem cluster or on a workstation or in the cloud, and then let Converge run that simulation. And then after that, of course, you need to be able to post-process and visualize your data. So we will write a set of 3D output files as well as more 1D output files, things like temperature and pressures over time, that you can then interact with in whatever visualization software you choose. However, if you use TechPlot for Converge, which is our recommended post-processor that comes bundled with the Converge installation, you don't need to do any sort of post-processing on the 3D output data. TechPlot can actually read that data directly, so it allows you to kind of bypass any post-processing step. I'm going to touch a little bit more on our meshing because I think this is sort of one of the most important parts of Converge and something that we're very proud of. So Converge allows you to specify a lot of different inputs that control how we generate the mesh, but then the actual mesh generation is done completely at runtime. So you can see in this example, you can run with just a fixed, constant mesh refinement grid, but you can also add different types of ways to apply additional refinement to that grid for your run. So we allow you to specify whether you want to refine the mesh spatially or near some walls or some other boundaries. But we also have a feature called adaptive mesh refinement. And this is a really powerful tool for accelerating your CFD simulations because it allows allows the solver to automatically add and remove mesh refinement where there's actually flow features that are happening that you want to capture. So we have a lot of different parameters you can set in order to tune your AMR to really capture just the important features in your simulation so that you don't add more mesh if you don't need it. Converge's automatic mesh generation can also very easily handle very complicated moving geometries. Things like pumps and compressors, internal combustion engines all have very complicated moving parts, and we're able to consistently and robustly mesh all of those as well. So these are just a few examples of some industry applications that we've used Converge to simulate. So you'll see a lot of things like compressors, atomizers, which is a good example of some of our really powerful spray modeling tools. We have gas turbine combustors, IC engines, of course, were huge in the internal combustion engine market. Various tank sloshing things, and some other pumps and valve type compressors. So now I'm going to talk a little bit about some of the improvements that we've made in Converge 3.0 to really try to help take advantage of all of the cloud computing resources that are now available specifically Rescale, as well as other partners we have in the cloud computing industry. So older versions of Converge, it was a parallel application, and you could run it in parallel. However, it was designed from the perspective of, at the time, people were only running cases up to 64, 128 core type things. So there were some bottlenecks in the older versions of Converge that really started to become a problem if you wanted to try to push your simulation up to 1,000 cores, 2,000 cores, those types of numbers. One of the major ones in 2.x versions of Converge was that each processor in those older versions of Converge stored some information about the entire parallel structure. And that really meant that as you increase the number of processors, you actually would start to add a higher and higher and higher fixed memory cost on each of those processors. And so once you got above, a few hundred cores, especially when you started to get toward 1,000 cores, this became a huge bottleneck for memory. The industry is sort of heading towards smaller amounts of memory per core in order to, get those cost savings. And so, if you only have 2 or 4 gigs of memory available per core, 2.x versions of Converge would very quickly limit your ability to run in parallel just because of the memory requirements. So for Converge 3.0, we've completely removed all these bottlenecks. We have really good memory scaling now, and I think we're really proud of how well our memory scales as you add more and more cores to the simulation. So this is a simple plot here of just a single snapshot of a case, but you can see that Converge 3.0, which is this red line at the bottom, is something like a factor of 4 times better total memory consumption than Converge 2.4. And this gap is going to just continue to grow as you increase the core count. And you'll see that allows us to run really, really high core count cases without having any concerns about memory. So the other major one, and maybe the one that's even more important for running in parallel, is just being able to get good parallel efficiency. If running on more cores doesn't decrease your runtime, there's not really any value in adding those cores to your simulation. So the main problem we had with Converge 2.x versions was that we partitioned the domain at sort of a very coarse level, which meant that when you had simulations with a lot of different mesh refinements, it was very difficult to capture those refinements and still get good parallelization and good scaling. So in Converge 3.0, we've changed our load balance structure so that now we can put any mesh cell on any processor, which means that we're able to get a good load balance for any case setup. You can run any number of different mesh refinement levels with complex moving geometry and all that sort of exciting things, and still get a really good load balance, which means that we can push Converge now to thousands and thousands of cores without running into a problem where we're no longer able to distribute work evenly among those cores. So I've got a couple of scaling plots here to show some of the improvements in Converge 3.0. So this particular plot is a fixed mesh case based on the Sandia FlameD case setup. So the FlameD is a burner that is of particular interest to the gas turbine community because it's used very frequently to sort of validate CFD codes and different combustion models. So in this particular case setup, we have 48 million volume cells. We ran this on 28 core Haswell CPUs. And we're able to push this with nearly linear speed up all the way to 2,800 cores and beyond. But we did run out of CPU hours for this study. And this type of thing you'd be able to very easily run on Rescale. So another simulation we wanted to kind of show off the scaling capabilities of is a internal combustion engine, because a lot of our customers run internal combustion engines. That's what sort of we're known for. And we wanted to be able to show that Converge 3.0, you can really take an internal combustion engine and push the limits of scaling and really get fast turnaround time on some of these simulations. So this, we just took an example case that we ship with Converge Studio. It's a setup that we would recommend customers run for this type of engine. It's a pretty small case setup, so there's only 1.3 million cells at the maximum cell count, and it'll go all the way down to 230,000 cells. This is run on 28-core Skylake CPUs. You can see here that the scaling in Converge 3.0 really sort of dwarfs what 2.4 and previous versions of Converge were able to do. So we're able to hit 75% efficiency at 448 cores here, which is quite good considering that the average number of cells in this case at that core count is only 1,500. And the thing I think we really want to highlight with this is that with this new scaling that you're able to get out of Converge 3.0, you're able to really increase the number of total cycles per day that you're able to get out of an engine simulation. And this is really important because when we run gasoline combustion engines in particular, we see a lot of cycle-to-cycle variability, which means that you need a lot of cycles of data in order to really get meaningful information out of that simulation. So being able to get a faster turnaround time on these cycles really improves industry's ability to use Converge as a predictive and modeling tool for engines. So that's all I really had as an intro to Converge. Jolie, I think I will hand it back to you.
All right, great. Thank you so much, Cooper. And I think at this point, it doesn't look like we have any outstanding questions. So if you do have any questions about what we just saw, feel free to write those in the question box again. And at this time, I will go ahead and turn the time over to Bernardo. Bernardo, can you hear me?
Yes, I can.
All right.
Thank you, Jolie. Perfect. And thanks, Cooper, as well, for that outstanding overview of Converge. Certainly impressive, to see all the work that has been done on Convergent Science to take jobs that were typically running on 100 cores, and now we're talking of 1,000, 2,000 cores. So that's a complete, a dramatic, transformation and truly scaling up. So now let's talk about having the resources, that's going to help you get that. And first of all, I want to talk about, what's that process? Why are people are now starting to look more into cloud? So certainly there are different aspects, and one of them is cost. The cost of owning, an HPC environment. It's no doubt that it's a large capital investment, sometimes in the millions of dollars in order to have an environment that has thousands of cores available to you. And you always have that risk, right? That challenge. If you are conservative in the size of your cluster, well, now you're going to force a queue in your users. And then if you really plan, for a large environment so that your users never face that, well, you're going to have some downtimes. And, well, your asset is just going to be sitting at times without any use. So, of course, right, the cloud in that regard has all the flexibility so that you can transform and make an operational expense that you can then pass on to your engineering business units. And of course, you can optimize for either the people that you have, make sure, that they can always get the resources that they have, maximize for software use, or just have, flexibility of hardware. Now, what's another constraint? So licensing, right? In some cases, licensing, can be a blocker. Long-term commitments, locked-in licensing for a year. However, right, we know that projects might come at certain times where you just need the resources to meet that demand, right? So certainly, having Converge available on demand as we have it on Rescale and have that dynamic allocation of resources, not only on hardware, but also on software, allow us to truly now speak about that scaling, right? That flexibility that you'll have from both resources. And finally, right, I mean, what are the challenges of HPC resources, right? I mean, if after considering cost, after considering licensing, well, the fact that it's a single site and probably, I mean, they picked for a fixed type of processors in that environment, right? Probably the latest and greatest, but then, I mean, you're fixed for the lifespan of that cluster. And typically that's 3 to 5 years until you're going to see a renewal of the hardware. However, right, I mean, we all know that Intel, AMD are releasing new chipsets almost every quarter, every 6 months now, and new hardware is available. So certainly in the cloud, having access to different resources as they get updated, multi-cloud providers that can be leveraged to access, then you can have almost an instantaneous access, right? I mean, to those virtually infinite HPC resources. So these are just, you know, 3 of the reasons why people are migrating to cloud. We're looking, I mean, to see like if you have other ideas, right, or other questions, other challenges that might make you consider, right, a cloud, and feel free, I mean, to put them in the chat box or let us know. So now talking about Rescale, right? I mean, so what is Rescale? For those of you not familiar with it, very simple. Rescale is a web-based platform that gives engineers, researchers access to run all of their CAE applications, their preferred ones, certainly like Converge, to run leveraging the hardware from all the cloud providers that we partner with. And certainly, right, I mean, it's all the broad of the big players that you've heard of: AWS, Azure, Google, IBM, Oracle, other bare metal providers. And certainly you can leverage the capabilities from all of them, all through the same interface, right? We really take the burden of providing a fully integrated stack to make sure, I mean, that you focus in what matters the most to you, right? What matters most to you is not necessarily, I mean, the cloud infrastructure or the administration of those resources. What matters to you are your products, right? I mean, your services. And that's really the focus, and we want to make that happen for you. And on that regard, right, maybe we can take a quick, you know, step back and just look at, you know, what is behind an HPC stack, right? What do we even mean by that? So this is really all the different aspects, services, tooling required in order for an HPC administrator, I mean, to provide, I mean, those hardware resources to you. Starting at the bottom from basically just the physical housing of the data center, all the way to the network, operating systems, middleware, tools, application, right, and all the even all the scripting being required, I mean, to tune these applications and make them available to you. So that is certainly not a simple task, and no wonder, I mean, it keeps a team busy to have those resources for you in any large enterprise. So where does Rescale fit? Well, pretty much everything, I mean, that you see in blue is what now we offer through our portal. And you can see that right at the bottom, right? Of course, the data centers are owned by our cloud partners. So that's certainly, I mean, taken care of. But everything starting from there, networking, operating system, and making sure that those applications are tuned and ready to be used on all the different hardware available on the cloud really makes a big difference in how you can access and consume cloud without, you know, worrying about all the administration and the complexity that comes with it. And now we can also talk about, yes, right, I mean, how do people, I mean, typically on-prem get access, I mean, to new core types, right? And what does that cycle look like in a typical scenario as new generation of processors become available? So here, I mean, we can take a snapshot of the last 7 years, right? And we start, let's say, I mean, with an environment that has, at the beginning of 2013, only Ivy Bridge processors. So what's the typical, I mean, to happen? sure that once new core types or new processor technologies, new processor architectures are available, are they all going to be, replaced every quarter and made available, to the users? No, most likely it's just going to be a portion of it, because you still have a resource with Ivy Bridge, right? That you spend a lot of money and time to set it up. So every quarter, you might increasingly add more of this Haswell processors, and then you get to 2014, and Broadwell comes into the picture. So are we going to replace the entire cluster? Well, no, we still have that resource, right? And you're just going to add a tiny bit, and you can see that, right, all the way until we get to today, right, with the Cascade Lake processors. Now, in the cloud, well, certainly data centers in the cloud are much, much bigger, and you can have access, like once Haswell, right, hits the floor on the cloud providers, there's really nothing stopping you from switching your entire workload onto that architecture. And when Broadwell comes in, you can immediately take advantage. So you can see how with a cloud you have not only flexibility, but you're staying up front, right? With the latest and greatest to make sure, you get the best performance out of your simulations whenever new hardware becomes available. So this is also a dramatic shift on the way of leveraging the hardware resources that are available. And we can't talk about multi-cloud without addressing one of those key aspects, which is choice. And what do I mean by that, right? And you can see here that I have 3 graphs, right? And without getting into the details, these all correspond to the same model, right? But just look through different lenses, right? And these are all comparing different core types, different hardware that we've used. And what I'm trying to say here is that we know that all problems are not made equal, right? Certainly if you were running 2.4, right, as Cooper mentioned, that was more memory bound in terms of its processing. So in those cases, you might want to have access to resources that have more memory. If you're now going to 3.0, that's no longer needed. So you probably just want a processor, with a fast interconnect or a faster clock speed. But that's not the only variant, right? Of course, also during your life cycle, during your development cycle, things change. There are cases in which you're on time, you want to minimize costs, but there will be cases in which you have that burning need, right? That peak project, that deadline that needs to be met regardless of cost, and you just want to have access to the fastest hardware available. So again, that's something that when you're constrained by just a single hardware option, you're not going to be able to do. You're not going to be able to react. But once you have access to multiple resources, multiple cloud providers, you're going to be able to make that decision. And certainly Rescale and our team of solution architects and HPC engineers can provide guidance into what is the optimal core type depending on what your goals are. So now enough talking and sharing slides. Let's go and jump into a demo, right? Because we've talked about how easy it is to set up a job on Rescale. So now let's take a look at it, and I'm going to switch and look at our platform. So in here, right, I have a clean workspace right after I log into my platform, and I have a simple menu on the top that is going to guide me into just quick settings that I need to access, right? To set up a new job. So I'm just going to go straight for it and define a new job. And of course, right, it prompts me to give it a name. So I'm just going to be super creative here. And I'm going to call it Converge Test Job. And in here, you're presented, with a straightforward workflow, right? We tried, to maintain our interface clean and easy to follow so that anyone, can go ahead and take advantage of Rescale, but of course, it's not the only way to interact with it. We certainly have our command line interface, our underlying API for people that want to do some more complex work or complex integrations with our workflow. And we start by uploading some input files straight from your computer. They're all encrypted in transit, encrypted in rest. Security is certainly at the top of our priorities here to handle data in the cloud for you. But in my case, I already have some files in my cloud storage, so I'm just going to go ahead and pick here one turbocharger compressor that we're going to run in the cloud. And you're going to notice something here, right? I mean, this is a zip file, so certainly we support all sorts of different versions of compressed files because we understand, right? I mean, that we want to minimize the data that it's been transferred, right, and upload it to the cloud. So you certainly can upload compressed files. Those will be automatically extracted in the cluster when you start a simulation. Now, if you have, let's say, a partial run and you have some restart files, you just need to include them in your inputs. If you have a user-defined function, SO libraries, right, you just need to include them here as your inputs. And now we're going to see how we're going to set up this job. So we look at software. And in here, we have access, right? I mean, to certainly Converge 2.4, Converge 3.0, and we carry pretty much every version of Converge. I mean, starting, when it was first released on the beta versions, some customers wanted to use Rescale to beta test 3.0. And of course, with in cooperation and coordination, with Convergent Science, we gave them access, to try it out. So some people also leverage, right? The fact that Rescale will have those applications ready as a way just to try it out, new versions, without having to necessarily install them locally when they do that. So just go ahead and pick your version. And in here, the command couldn't be simpler. Of course, this converge command, it's a wrapper script, and behind it, we're going to be calling, right, and make sure, that we coordinate and orchestrate the work across the processors, across the nodes that we are going to be provisioning from the cloud. But for the users, we just wanted to make it as straightforward. So even if you have a user-defined function, even if you have restart files, all we have to do is converge. And we will automatically find those, identify your input files, and we're going to be executing that job. Certainly for licensing options, one of the most attractive aspects is to have access to on-demand, right? So this is something exclusive, right, to Rescale in our partnership with Converge, which is having access to on-demand license. And now we talk about a fully flexible, fully scalable resource that you have, not only on the hardware, but also on the software side. So this is going to be very, very powerful, especially when we look at 3.0 being able to reach into the thousands of cores for your simulation that ultimately translate into faster time to solution. More cycles, as Cooper was mentioning, right, per day, that ultimately means more answers, right, that you're going to be able to test in the same amount of time that you had before. But of course, if you have an existing license, we can certainly connect into your license server and leverage that as well. So now I'm going and move into the hardware settings. So in here, we use mineral names, but certainly we leverage now all the power of our cloud partners. Different clock speed, different memory, different interconnect, depending on your needs. All of this that you're seeing can be fully customized. You don't have to necessarily see or get lost if this seems to be a daunting list. This is where our expertise will come into the picture. And we're going to guide you into choosing, and then we're going to customize it. So only the options that you identify are the most useful become available to you. You make your hardware selection, and now you can truly start scaling up, right? We have people, that are running into the thousands, right, into the tens of thousands. So certainly now with Converge 3.0, you can surely go and truly scale, picking, right, I mean, the number of cores that are giving you the performance that you want. And after that, all you have to do is submit your job, and then you'll be ready to go. So here, I already have a job that is running. Just to fast forward a little bit in the small time, I mean, that we provision the resources. And one of the key aspects that we have done with Converge is the ability to give you all the tools that we could have for monitoring your run. So straight out of the Converge logs, we created this dashboard, right? I mean, just to present you some stats out of your run. Some of them include progress, right? I mean, load balance and some dynamic trends, but that's not the only ones. You certainly, I mean, can have live tailing, which pretty much allows you to look at partial results, right? I mean, let's see if I have my Converge log file, and then I can just scan it here and review the progress, right? And any of the intermediate output files that get generated. But also for some of our advanced users, we certainly have the ability to SSH straight into the cluster from your browser. And from here, you certainly have, you know, full access into the monitoring of the resources, and even, right, I mean, reading or extracting some of those results as they are generated while the job is running. Once the job is complete, we're going to copy your output files into your result storage, and that cluster is going to be shut down, right? I mean, all the data is destroyed, and your results are available in your cloud storage for you to download, or you can also post-process in our remote desktops, which is something that our customers really like to do. So we have different options for desktops, whether they are hardware accelerated, right? I mean, with GPU attached machines, or different offerings of Windows environments that may leverage different memory or different storage. And from here, you can choose to add Converge Studio, TechPlot for Converge, and attach your result files. So once, I mean, you load one of these machines, you're pretty much inside a Windows environment, very familiar with it. And now you can open Converge Studio. You can look at some of your results right here, validate that everything looks good. And also, right, I mean, if you want to open TechPlot or, you know, some other post-processing tool, you certainly have access to them. And the last portion, of course, right, we certainly have a lot of resources in our documentation, examples, tutorials, right, I mean, that can guide you through the process of running your first job on Rescale. So certainly you can go ahead, right, sign up for an account on Rescale and, you know, pick one of these examples, I mean, to do, I mean, some short runs. And you can certainly reach out to us. We want to hear from you and certainly help you get the most out of Converge on Rescale. The last thing that I want to share with you today is just some runs, I mean, that we did with 3.0. And again, this just is to show you some of the behavior that we've seen with 3.0, right? And here we're picking two of our latest core types. Well, Emerald is, I think it's been around, I mean, for a few years, but it certainly has tremendous processing power. Carbon, some of the leveraging one of the latest Intel architectures, and seeing that now we're running a model with 30 million cells up into the thousands. And when we look at scaling, well, we can see that even at 1,080 cores that represent this data point, we're at 70% from ideal scaling. So that is truly a tremendous shift, right, from 2.4 or yes, right. I mean, 2.4 previous performance when we were talking on the hundreds, and now we're talking into 10 times that, right? And giving you the performance that you need, faster time to solution. So with that, I'm done with my presentation. So I'm going to turn it back to Jolie.
Great. Thank you so much, Bernardo. It looks like we have a few questions, so we'll go through those. And the first one is from Jason. Says, I sometimes work with custom builds of Converge. How are these supported on Rescale?
That's a great question, and that's very common for sure. So again, right, try to make things as easy for our users. All you have to do is include that custom build as an input file, and would you just run Converge with a -B. All of this is documented in our resources, but it couldn't be more straightforward. So you don't have to worry about installations. You don't have to worry about, waiting, right? I mean, for us, to make it available to you. You just treat it like another job that you're setting up, and you're running a custom build.
Great, thank you. We have another question. This one's from Gary. Gary asks, what are the entry-level costs for the software license and computing services?
Yeah, great question. So certainly, we would like, to discuss this further with you. We certainly handle different pricing plans, and we want to make sure, that we meet your needs. But certainly, for software, it's extremely attractive, right? So for that, we're going to reach out to you, Gary. We want to have one of our account executives, to discuss so that we truly tailor our offering, our pricing to meet your needs.
Thank you, Bernardo. It looks like this question is for Cooper. This is from Sarah. Is the meshing in Converge really fully automated?
Yeah, thanks. That's a great question. This is one we get a lot, especially to new users of Converge. Yes, the meshing in Converge is fully automatic. It's one of our biggest selling points. The only thing the user needs to do with respect to the meshing is provide a clean, watertight surface file that represents the model you're trying to simulate. I can also say that with Converge 3.0 and newer versions, they're going to be coming out next year. We do allow the user to specify parts of the mesh if they choose. If you have a specific mesh shape that you want to run, you can actually include that in your surface and set that up in Studio, and will allow you to specify, parts of the mesh if you want to put a specific type of mesh where you're having some spray or around to capture some boundary layer effects and things like that. And that's called inlaid meshing. And of course, you can look at our documentation for more information on that.
Thank you, Cooper. It looks like we have a couple more in here. I apologize if I say your name totally wrong. Satyam says, can you please also talk about potential cost savings with higher number of cores in Converge 3.0, since license cost per hour is typically higher than cost per hour of cores? That one must be for Bernardo.
Yes, and that is a great question. So as part of our partnership, right, and looking, to really extract the most out of Converge on Rescale, Converge, and Convergent Science, has a tremendous offering, right, on pricing, for on-demand. So with their approval, right, you get access to running on-demand, and the pricing structure is as follows, right? You have $3 for the first core, 50 cents for any incremental core. However, it is capped at $12 per hour. So what does this mean? So if you're going to run 100 cores, if you're going to run 1,000 cores, or if you're going to run 5,000 cores, you're going to pay at most $12 per hour for that job. So really, a really tremendous, right, deal when you're looking to go large and scale on Rescale with Converge on Demand.
Thank you. And then Bradley asks, able to run multiple jobs in one workflow at the same time on different software apps?
Yeah, I mean, certainly, I mean, we have a lot of users that are running jobs in batch. And then if you want to not leverage like different apps, we can certainly work with you and show you how we, basically our functionality to run jobs in batch. And we can certainly create work with you and provide a framework in which you'll be able to access multiple apps. That's something, I mean, that our users, especially running Converge, leverage quite a bit, right? When they're running multiple engine cycles, right? They don't go and set up each job individually when they're only changing one parameter. So I certainly look forward, I mean, to discuss this further with the person, I mean, that asked this question, right? I mean, because that's certainly how we also extract a lot of benefit from running in the cloud, not only scaling vertically in a single job, but horizontally, like going wide, running a lot of jobs in parallel, for sure.
And Bradley had a follow-up question. How simple is it to share results and further analyze as a separate user?
All it takes is a click of a button, right? I mean, so certainly, I mean, for security purposes, all the data that you upload to the cloud is only accessible to you. Not even Rescale has access to it. However, you can share it with teammates. You can share it with Converge support when you have questions about the application, and you can share it with Rescale support when you have questions about the setup. So your colleagues can look at jobs not only once it's complete, but also while it's running, and you can share them and have them take a peek as your simulations progress.
Great, and it looks like we just have one more question if no other ones pop up here. And Bradley says thanks, so does Satu. And the question is there a way to prepare my Converge results for TechPlot automatically after my simulation is complete?
Yes, well, certainly as Cooper mentioned, right, and part of their work that they have done with TechPlot is able to read Converge output files directly. So that certainly makes things as straightforward as they can be. However, also in the past and for other versions, we were able to run post-convert directly in batch. So you didn't really have to open Converge Studio and prepare your jobs for the post processor. You can do that automatically right with the command that you're running your simulation.
Okay, perfect. That question was from Jamie. It looks like we don't have any additional questions. So at this time, we'll go ahead and wrap up the webinar. Thank you all who were able to join us. We'd like to remind you again, our next webinar in this series will take place on July 1st in a couple weeks from today. Have a great day out there and stay safe.
Thanks everyone for joining.
Thanks everybody.